All right, thank you. Sorry for the delay there. I'm Dave. I've been working on MoveIt for a long time. Now with Picnic, and today I want to talk to you about how to make your ROS software better, your robotic software better. We're all here for open source, and I think open sourcing your software is great, but I want to encourage you today to take it a step further and make it easier for developers to use and to get started with it. And so the target I'm talking about is not the end user who maybe has no idea about robotics, but for us developers, for us roboticists, software engineers, regular engineers, all sorts. And so the outline is the unique challenges that we face making robot software, why we care about what I'm proposing today, and then I'm going to present 6 entry barrier design principles of how to make your robot software better, and finally give an example with MoveIt, the setup assistant. So first, I think we all know, and if you don't know, you will know soon, that robot software is hard. And the reason why is because there's a lot of things going on at once that we have to account for. And we all agree that we're going to work together on this because we can't all do it ourselves. And that's why we're here at ROSCon every year, this year. So some of the unique challenges that I'm sure we're all familiar with is the domain knowledge is enormous. Not only is it the hardware at the low level, firmware, mechanical engineering, electrical engineering, the drivers, the middleware, which a lot of the talks you hear about, this just the complexity of ROS2 middleware. But then on top of that, you have all the algorithms from your perception and your motion planning, and your kinematics, or your SLAM, whatever type of application, your drones flying around. And that's the large complexity and scale of robot platforms. I just mentioned drones. It's crazy to me that ROS can run on a PR2 and on a drone, and for a robot arm standing fixed to the ground, or maybe a robot arm with two arms, or it's a walking humanoid, and we're all trying to do the same software for this. It's a pretty complex problem ahead of us. And the factory environment is pretty structured, we all know. It's been a lot easier, we've had a lot of success over the past decades, but the unstructured real world provides a whole new slew of difficulties that we don't see in web development when you're just fighting a few different browser compatibility types, or iPhone versus Android. We're facing like so many different challenges if someone left something on the floor, or you're in a logistics warehouse and the shelf was left in the wrong place and the robot doesn't expect that, as we saw yesterday. And then one thing that's interesting about our work is that I want to propose that we have things that make it easier to use the software, like user interfaces, but at the same time, we have the objective of getting rid of user interfaces and having the robot work with us more naturally over time. And so that's kind of a weird paradigm of let's make all these buttons and faces like ease of use, and then the ultimate goal is to get rid of that and just talk to it, like Alexa style. So the barriers to entry is when you pick up a piece of software, you're searching on ROS Wiki, and you find, oh great, this is the algorithm I need, and now you have to ask yourself, can I actually use this piece of software? How long has it not been maintained, or does it only work on Hydro? Has it been catkinized yet? Hopefully we're not asking that question anymore. But here I define it as the time, effort, and knowledge that a new user must invest in the integration of that software for an arbitrary robot. And if it's too high, you're not going to use it, and then it kind of defeats the point of open source. And so how can we reduce those barriers? But first, before we get into that, I know you're probably thinking, like, I don't have time to write documentation. I have all these code sprints, these milestones. I have a paper to publish. I have 5 papers to publish. But by reducing the barriers of entry, you're actually going to have a larger user base. More people will be able to use your software, which is what we've seen with ROS. They had amazing documentation on how to use ROS1. Hopefully we see that for ROS2. And that resulted in better software for all of us because more people are there to address problems. So there's research behind this. As the number of users increases, bugs are typically identified and fixed faster. I know some of you guys are thinking, oh, that's not true. I've seen the pull request list. Like, it's enormous. There's so many issues. But I guarantee you, if one person had done this themselves in a lab and never touched it, there'd be so many more seg faults and problems every time you have to change computers, installing the software over from scratch. Like, oh, I didn't document how to install that this time. I forgot this dependency or that. So that's a benefit of getting more people involved. The quality assurance is similar. People adding to the documentation, so that you forgot to add this step. Someone goes in there, edits the wiki, or fix the readme.markdown file. And finally, things like ROS Answers. You have people who can answer questions about someone else's software even though they didn't write it. That's pretty cool that we have a community here that's supporting each other. And I know these are ideals, and it doesn't always work out this way, but it works out pretty well. And so this is just kind of a motivation of why we want these larger user bases for our software and not just putting the code out there for anyone to use without making it easy for people to use. And finally, there's this, for larger user bases, new feature contributions increases. This doesn't always happen because, again, this software is really complex. And sometimes there's just a few core developers who really understand deep inside of it, but there's still typically, you'll get more new features. So with our last talks, we just saw amazing work with TrajOp and with the collision checking and the MoveIt task instructor. I mean, I'm talking about MoveIt because that's the world I think about. But because there's so many people involved, we have these new features always coming in. It's really exciting. Open source software projects become more successful with all this. And then finally, by having things easy to use, we actually open access to grad students and labs, to undergrad programs teaching robotics. Intro robotics, a lot of them uses ROS. High schoolers use ROS. So there's a great thing here, and this helps your hiring pipeline because you have better people coming in that are able to do these skills, and it generally creates innovation. That was the idea behind ROS, was that it's going to be like the Linux, the open source web server world where anyone can make a website, anyone can make a robot application. So the 6 entry barrier design principles, want to jump into that. Immediacy is basically the hello world, and I think we should have more ROS projects that offer this. In MoveIt, we call this demo.launch. And it's the idea that once you get your robot configured, and I'll go more into that, you run a program and it just shows you the basic example of like, oh wow, I did that. And in programming languages, we call that hello world. Now, if it's a 3D robot system, it may not have the words hello world involved, but it gives you the idea. This is the demo of how to get started. In ROS, it's the Turtlebot, the middleware. You know, you can quickly drive it around like, oh great, I did something. And this is important because if you don't get that feedback, people get turned off. They're like, oh, this isn't going to work. This is going to take too much time. And they go and reinvent the wheel somewhere else. Like, they're like, oh, I'll just make it myself. And then it turns out that takes them years to do. But that's the problem, is that we got to make it that initial like dopamine hit of like, wow, this works. And then the other thing is that there's this paradox of the active user. What is the paradox of the active user? It's that users never read manuals. And eventually they will. But the problem here is that if you had just like read the documentation ahead of time, then you would have actually saved time than rather pushing buttons and trying to figure things out. But this is how human psychology is. It's like, we're just going to jump in. I do this. I don't want to read the documentation. But eventually you do. But so we want to make it as easy as possible to combat the paradox of the active user. So the next design principle is transparency. And that's that the steps for setting it up are both automatic, and yet they show you what's happening. And so it's not a black box where it tries to do everything for you without you knowing what happened, but it also doesn't make you do everything yourself. And so there's like these multiple layers where you can go like the quick start, and then if you're advanced, you can go deeper and deeper, and you want to make it so that people can see what's going on. So an example that the Linux users here, we all use Ubuntu, I think, for ROS currently at least. It's exciting news about the other platforms. But if you're installing Ubuntu, and typically you just want to like, this first option, you just want to erase it, install Ubuntu on top of whatever's there, and it tells you what's going to happen, and you say next, and it's great. But there's also this something else where you can choose the crazy partitions and other options. This is an example of software that makes it easy to get started, but also if you have this particular use case, it's transparently telling you how to go deeper. Reconfigurable is important, especially with our very powerful algorithms. There's always a lot of these magic parameters, all these dials you have to turn. This was a picture of a dashboard here. So we want to have a set of default values that work for most robots, but also the ability to change them later on, which is very similar. And so like if you want to have parameters that if you have a particular type of robot, maybe you need to tune it up or tune it down. If you PID control, maybe if you want to like reduce the error tolerance, you'll make the robot move slower. But if you want to have it go faster, then you don't care about the error. Just the ability to change these. So these could be YAML files, ROS params, configurations. Maybe it's something I dynamic reconfigure. These are great ways to make it easier for users to use software for different applications. And we want to make this more adoptable. And then intuitive is for user interfaces following common design paradigms. Maybe your local operating system puts buttons a certain way, or you're using a command line and you type -H, you're expecting the command line to give you a help function. And if it gave you a hamburger, it makes no sense. Or a -V, you expect verbose. So kind of following these conventions that we're all used to makes the software more intuitive. And extensibility means that you have an application you're solving for, but realize that other people want part of what you're doing, but it's not going to be the exact same thing. So making it flexible enough so they can take this piece and move it somewhere else and reconfigure it to work for their application. And that'll increase the adoption of your software because it's more powerful that way. It's something that ROS really nailed, of having all these different nodes connected by topics. And if you don't want that node, you take it out and put a new one in, and the topics connect differently, and you have a different system, but you're still using the same components, just reconfigured. In MoveIt, we're really into plugin lib. That is a little faster in terms of communication. Hopefully ROS 2 fixes that. But plugin libs we have 8 different types, so collision checkers, planners, IK solvers, etc. And if you don't like one piece of that, you can pull it out and extend it to your own research or to your own particular need. And then finally, the one that I think gets the most attention typically is documentation. And this is your wiki or your README. And you want to think about having different levels of documentation. So you have people who don't care about how the perception algorithm works. They don't want to know how the SLAM works. They just want it to work. You give them one set of documentation. But there's the person who really doesn't like the way it's done. They're a developer, they're working on their PhD, or they're in a research lab, and they want to dissect it. You need documentation to help them introspect, debug, change, modify. So you want to think about different users. Maybe you have users who don't even use a command line, or God forbid, don't use a command line, and you have to have a different set of instructions for like the high-level stuff. So that's another approach. And so I want to give an example, and I don't want to be. I had to pick a package from the ROS wiki to pick on here, but I think this is okay because several years ago in the Amazon Challenge, they actually beat us. Data speed, I think, got 3rd place. We didn't place, so I'm going to pick on them here just for this instance. But looking at the wiki here, they have this package called Data Speed PDS, and it's got this very short description that just says interface to data speed, power distribution system. But you'll notice there's no description under that about how to run it or how to build it or any of those things. And then the middle arrow is showing that there's no tutorials, which is a common paradigm, and that's okay. Not everyone uses the ROS wiki, but it'd be nice if you had a link to other documentation. So I click on their Bitbucket, and on the right side of the screen here, you see there's no readme.md, and then I click on all the packages, and there's no readmes in there, and then I Google it, and the only thing I'm able to find is a PDF several results down that has deep inside of it some reference to this thing, but I don't, just no documentation for what this is. So it's open source, but it's also not usable for new entry users. I guess they have customers who know how to use this, but it's kind of strange to me that it's on the ROS wiki. But again, these guys do great work, so don't take this to heart. Now I want to use the MoveIt Setup Assistant as an example of some of these. I think we've done a pretty good job as a ROS package on how to apply these design principles. So you guys just saw a whole presentation on the MoveIt Task Constructor, so I think we all know it's a planning framework, and then we saw stuff on TradJobs. MoveIt's been really popular because of this setup assistant. It's this graphical user interface that quickly gets you started, and I think this has been a game changer for the project. So I created it back at Willow Garage as an intern, and this first screen I'm showing here, you can either create a new package or load an existing one. And so here you load it up, and it shows you the robot on the right. It has a little window of RViz. So you already get feedback that, hey, your URDF has been loaded correctly. You could see it. Something's happening. And it's we're going to walk you through it. And on the left side, you see all these different window panes that you can scroll through and configure all these components. So it's very lots of good feedback to know that's working. And then this first screen, the second screen, the self-collision screen, it's pretty amazing. It runs tens of thousands of checks to optimize any arbitrary URDF, any type of kinematic robot model, to make this collision checking faster. And so you have this sampling density where you can tell it how many cores for how long to run, and then it generates this table. It's got nice colors, and what this is allowing you to do is not only do you take the auto-generated results of don't worry about it, just press this button, keep going, or you can go and uncheck specific things because maybe you have better knowledge that you don't care if these things collide, or you do care. You can override it. So it shows you all the different types, so it's color-coded to what type of collisions it's checking for. And then on the right side of the screen, you can also highlight the links and see the robot turn red to see which links you're configuring. So a lot of great feedback here. Then there's a number of screens that let you specify the metadata. Planning groups, robot poses, end effectors, passive joints, virtual joints. These are all things that matter to MoveIt so you know what a hand is versus what a leg is. and robot poses let you know what like a touchdown poses versus a ninja poses. So it gives you all these things you can do here. The GIF's showing you kind of some of the things that are available. Now I want to show briefly some new features in MoveIt that I think are really taking it beyond just the MoveIt planning framework, but allow you to now integrate to all parts of the ROS ecosystem. And I just want to kind of like put this as like an idea where we can add even more in the future. And I want to thank Mohammed. He was a Google Summer Code student who worked with us this summer at Picnic. And he and I built a lot of this stuff. So he did a great job with this. And Open Robotics, also, they were the sponsors of the Google Summer Code program. We worked with them. So thanks to them for some of this work. We now have a perception screen. So we had a lot of feedback from MoveIt users that you get dumped out with this demo. It's all simulation, but how do you connect it to the real world? And we had some tutorials and a little documentation and some example files, but now this actually holds your hand even further and says, just choose from the drop-down list what kind of point cloud. Is it a kinetic XTion, or is it an ASIS prime sensor, or what kind of like sensor you have, and then you can change the parameters. So change the topic. It gives you default values, but you can also up and down them. And there's still work to be done. This is still kind of an initial phase. This also, it's in it's been released, or sorry, it's in the code repository, but it hasn't been released into a Debian yet. That's coming up in the next month or two. But this is kind of an exciting example of how you can step people through each configuration step. The next one is we wanted better integration with Gazebo. And the thing that was missing, several things. There's extra URDF tags that you need to add, like inertia, and then transmissions and ROS control integration. And so this button just generates the output that you need to modify your URDF with. And we didn't want to actually do it for you because we want to make sure you realize that we're modifying a Debian. So this kind of just highlights, copy, paste, you put it in there. And then we have one for ROS Control, and ROS Control is needed for the Gazebo integration. But this also gets you the launch files and YAML files you need to connect to your Ethernet USB connection. And then finally, it outputs all this into a configuration package that gives you this demo.launch that is our hello world, and it gives you this screen. And it has interactive markers where you can drag and drop and press plan, and if you have the low-level piece connected, you can even execute it. So this is like the whole package of like how to get into MoveIt. Now, after this, it gets more complex. This is hard robot software, but this gives you a pretty far away. There's also been feedback about like bad tutorials. So the one thing we've worked on a lot this year, I encourage you to go back, is that we have all new MoveIt tutorials, and so pretty excited about that. We also had a sponsor for this, the Frank Imika robot, and as announced the previous talk, we have World MoveIt Day coming up. So as you go through this documentation, if you see issues, please submit pull requests or join us on World MoveIt Day to like help hack and improve this package. Again, it's October 25th. So concluding thoughts is that robot software is hard. And we're going to be open sourcing things, all of us together, but we also make it easy for people to use, but beyond just putting it on GitHub. Some of the entry barrier design principles will help you, will do that. And by building this community, you'll end up having better software. And then finally, I think personally that the MoveIt Setup Assistant is a good example, and I encourage you to add more integrations to the Setup Assistant. I'd love to have more like a plugin-based system where we can have all kinds of different configurations added to it. So I thank you for your time.
Any questions for Dave? Dave, I'm curious, do you have any advice based on your experience on how to collect this feedback from users? Sometimes we're too close to the code to know actually what would be useful to end users.
Just say something inflammatory on discourse. You'll get a lot of feedback. We have a MoveIt discourse channel, so in terms of MoveIt, you can go there, find the appropriate one. But yeah, there's the issue trackers, I think, is the more serious answer. Post on there, like, I think this is a thing. And the best thing is say, hey, I see an issue here. Can I fix it? Like, and I'm going to do it this way. Is that all right? And then go make a pull request, like, because we are all very busy. So just expecting it to be done for you sometimes happens, sometimes it doesn't.
Great. Thanks a lot.